Hello everybody, this is Mrs. Snook with section 6.2, Solving Systems Using Substitution. So if you remember from last time, you had a graph and we would have a line and then maybe another line. And the point where those two lines intersected, that was your solution. And that was to solve by graphing. So last time we solved it by graphing. This time we're going to solve using substitution. So this is going to be our second method for solving linear systems. And here's the big idea. You can model fair trades with a linear system. And you can solve that linear system by solving one of the equations for one of the variables, and then you just plug in that equation into the other equation, and when you do that, that's called the substitution method. And what happens is you get one equation with one variable, and that allows you to solve for that variable, and then you just go back, plug that variable into the other equation, and now you've got the answer for your other variable. So let's go ahead and do some of these so you can see what I mean. So the first thing I'm going to do is I'm going to look at my equations. So step one is look. And what I'm looking for is an equation that is already solved for one of the variables. And take a look at this one, y equals 3x. That equation already is solved for y. I've got y on one side all by itself, and the other side is just a bunch of stuff, in this case 3x. So I'm going to call this one equation 1, and the other one's equation 2. And because equation 1 is already solved for x, I can plug in equation 1 into equation 2. So I'm going to plug 1 into 2. So I'm going to take this 3x, and I'm going to plug that in there for that y. So when I do that, I get x plus 3x equals negative 32. So now this is one equation with one variable. That's what I mean by when I say solve it for one. So now I've got one equation, one unknown. So my next thing I'm going to do is I'm going to solve. So combine my like terms, I get 4x equals negative 32. Divide both sides by that 4, x equals negative 8. So here's one answer. Now I'm going to plug back in the other equation. So I'm going to take that negative 8, and I'm going to plug it back into equation 1. Because what I'm trying to do now is I want to solve for y. And the easy way I can do that, since 1 is already solved for y, is just plug in there. So I have y equals 3x, and I know x is negative 8. So that gives me y equals negative 24. So there's my other answer. Now the answer to this system, remember, it's an ordered pair. So my answer that I'm going to put in is this one. Negative 8, negative 24. Your assignment's on Delta Math, and it is going to ask you for the equation in this format. So when you're doing Delta Math, make sure you write it in this format with the ordered pair. All right, next one. What is the solution to this system? Use substitution. So first thing I'm going to do is look at the equations. I don't have one that's already solved for the other, but take a look at equation number 2. I have a plus y right there. So I can go ahead and I can rearrange equation 2 easily, and that will give me an equation where y is solved for x. So add 2x to both sides. And when you do that, you're going to get y equals 2x minus 3. Now this one is solved for x. So I'm going to take this y equals 2x plus 3. I'm going to plug it into equation 1. I'm going to take this, and I'm plugging it in right there for y. So 3y, which is 2x minus 3, plus 4x equals 11. I've got one equation with one variable. That's what I need. So I'm good to go. I'm going to distribute 6x minus 9 plus 4x equals 11. Let's combine like terms. So I have 10x minus 9 equals 11. Then I'm going to add 9 to both sides. I get 10x equals 20. Divide both sides by 10. And x equals 2. So I got my first answer. I got 2. I'm going to plug 2 in. I could plug into equation 1 if I wanted to. But take a look at equation 2, which I already rearranged. Just plug in there, because I'm already set up to solve for y that way. So y equals 2 times 2 minus 3. Y equals 4 minus 3. That gives me y equals 1. There's my second answer. Final answer to put into Delta Math is going to be 2, 1. That's my final answer right there. All right, next one. We're going to use substitution to solve this system. And again, I have 2 equations. Look at the equations. You should see that equation 1 is already solved for y. So plug equation 1 into equation 2. I'm going to get 3x minus 11 minus 3x. So just as a reminder, this was y. I have minus 3x equals negative 13. Now combine like terms. 3x minus 3x, that's a 0. Minus 11 equals negative 13. No. Negative 11 does not equal negative 13. Okay? So this one, negative 11, does not equal negative 13. This one means no solution. If you remember from last time when we were graphing, if the graphs were parallel and they didn't intersect, you had no solution. All right, let's go to our next one. We're going to solve the solution of this system. Again, we're going to use substitution. Now check it out. This x is already equal to negative 2y plus 4. So my first equation is already solved. This time it's solved for x in terms of y. So I can take these y's and I can plug it into equation 2 for the x. So when I do that, I get 3.5x. So here's where I do my plug-in. Negative 2y plus 4 plus 7y equals 14. Now I'm going to distribute negative 7y plus 14 plus 7y equals 14. Check it out. I have a negative 7y and a plus 7y. Those add up to 0y, so they drop out. And I get 14 equals 14. That's true all the time. Always true. No matter what you choose for an x and a y, when you plug in, you're going to get something that's true all the time. So this is infinitely many solutions. Infinitely many. And what that means is It doesn't matter what x and y are. They're always going to work no matter what. And if you recall from last time, when that happened, when we were graphing, that was when the one line laid exactly on top of the other line. And so every xy worked. Infinitely many solutions when this happens. All right, that is it for today. Thank you for watching. Have a great day.